Okay, so I think I got. I don't see how many numbers I've got here, but I think I've got everyone. First off, can everyone see my screen, me projecting, or do you see whoever is made the last sound? Okay. Um, then I'm going to go ahead and the next thing we're going to look at is the working with strings, and actually working with strings as arrays. So today we're going to look at character arrays and and a little bit about how a string is stored underlying, underneath it all. And this can be useful to us because in the current program, you kind of need to dig things out of the string. So you might use a get line to get information out of the file, but then you need to search for individual words inside of the program. So in C, or early versions of C, we didn't have strings; we had character arrays. And if you think about it, a string is basically just is a sequence of characters. And an array would be a logical. Also, if you could mute if you're not speaking, that would help us out. I think I hear someone's kids running around or something. The character array basically is the underlying data type to store string information. And what a character array is, it's a one-dimensional array, which is null terminated. And right here we see this \0. That's actually the null termination character. So your strings that you've been using have all been these underneath it all, been these arrays of characters with a \0 at the end. So to declare a null terminated character string, you would do it this way. You would say char variable name, and then you would provide the size of your array. So, for example, name 50 could store 50 characters for a name. File name here could store 40 characters for a file name. Zip could store 15 characters for a zip file. Strings are a little bit better than character arrays for most purposes, because the strings kind of, you don't have to specify how large they are. It figures it out. This is also why strings are kind of are considered immutable, because arrays don't change size. So when you start concatenating strings together, what you're really doing is you're making a new string in memory, a new character array in memory, which is the size of both of those strings put together. So let me bring Socrative up, if I can find which one this is. I'll probably just go dynamically on this. Okay, so let's see where am I at. So declare the. So if you go to SpecReview.com and log in, declare a character array called student name that can hold up to 75 characters. Does everyone see SpecReview pop up? Ah, yeah, it looks like people are figuring it out. Yeah, I think people are getting it. So go ahead and log into SpecReview, and you're just going to see. I'm doing this with the dynamic question feature that they have. So, yeah. So I think this seems like it's working pretty good. Does it sound about the same as Collaborate Ultra, or is it worse? Just kind of curious about the quality of this.
Your audio is choppy.
Right on. Yeah, I get choppy audio from the other side too. That's interesting.
Probably it's your microphone.
I got a pretty good microphone. Wonder if I've got two microphones on. Hold on. Well, we'll continue on, and then I'll work the audio issues. Oh, you know, the other part is I'm doing a record function, too, so I might be overstressing everything.
Sometimes our internet provider is weird on Mondays.
Oh, really? Okay. I've been informed that our internet provider is weird on Mondays, so it might be it. Okay, let's see. Yeah, I think everyone's kind of getting it. It is, we're going to be doing, let's see if I can... I'll do it this way. So it would be char, and then the name of your, what you want to call it, and then the size. So this is a little different than declaring a string. You know, if I was making a string, it would be string student name. And the difference is that student name would be initialized when I initialize it to, you know, whatever. This is when it would actually, C++ would count up the number of characters and make an array, a char array of this size. So sometimes when you just want to preserve a specific amount of space beforehand, a char array can serve better than a string. You can initialize character arrays kind of the same way as you would initialize any other array. So you can make a comma-separated list of characters, but you can also do it with the same way as you do a string. So you could actually do this. You could say character array line, line, which has 15 characters in it, is I love C++. Now notice what happens. Here's the section of memory that's being used. Line at index 0 is going to be the I. Line at index 1 is a space. And then you have all the other characters. And then these null termination characters are inserted automatically wherever you don't have anything. So this is how a character array can be initialized using basically a string. Does that make sense? So it should feel pretty cool because you're kind of understanding how a string works fundamentally. And then so let's do let's try again, and this time let's declare that array student name, and see if we can initialize it to whatever your own name is. So go ahead and try to go to Socratic and type it in there. So in that case, what we would have would just be what you had before, and then you just put in, for example, whatever you wanted. You could also do it this way. But that would be painful. So I recommend the first method. Okay, so the null character, first of all, let me double check. Can everyone hear me? Okay, good. So the null character used to indicate where the end of the data is located. And for most of your day-to-day work with character arrays, the null character is placed into the array automatically. So when we initialize it with that string, it will C++ will put that null character in. It's important to remember that all the character array functions provided in the string library and the output functions in the IO stream require that null character at the end in order to work. If it's not there, you'll probably get some kind of error message that says memory overrun or something of that nature, because what it will do is it'll keep looping through everything in memory until it finds it. Well, if it doesn't find it, it'll quickly blast through all the memory that's available and then gives an error. So if we look at this string object, this is a text string object. Notice here we're going to make a string, and then we have CPP love of 20 equals I love C++, and then we create no null text 20. And what they do in no null text is, just as an experiment, they assign every character into every element. I mean, you would never want to do this, but and then no text is basically just 20 characters. And so here we have no text, which is 20, and this goes into remember, with the stack, everything kind of goes in backwards. So string object, which is the first thing, is this is a text. This text is in string object. And then it's CPP love. It says I love C++. And because it's a we declared it the string, we get a null character. Now, no null text, because we're signing direct, we declare it. But the way we're initializing is we're putting whoops no null here. We're signing these directly in, but we're not assigning the rest of the text. And then no text, notice that we declare it, and we're not putting anything in. And so let's see what happens. And what you'll end up getting is, basically, if you don't declare things initially, you remember how, like with just regular variables, you get trash. Well, you get the same thing with arrays, except that you just get a lot more of it. So if you were to run this code and output what you have, when you output string object, you get what you would expect. This text is in a string object, and it works just fine. I mean, that's basically what you've been doing all this time. But if you were to, and then if you output C++ love, it works fine too, because it's a properly null terminated character array. But with no null text, if you didn't put an error, notice what happens. You get whoops no null, a bunch of weird characters, and then it says I love C++. Why does it display I love C++? I mean, we assigned I love C++ into CPP love, but when we display no null text, it displays whoops no null, a bunch of stuff, and then it displays that one. Any ideas? The null characters indicate the end of a string, so without it, it doesn't stop. Yeah. And cout, which is part of the library, it depends on that null character to stop, as you say. So as it's reading through this, it gets through whoops no null, that's fine. And then since we didn't declare anything after character 13 through 20 are these weird characters. By the way, if you look up in the ASCII code library, let me bring that up. There's a site called ASCIItable.com, which actually lists all the ASCII characters. Notice these little characters here. These are actually ASCII codes. And if we look at that one, that was the double line with opening to the right. It's one of these. But you notice you have all these graphics characters here. The reason they had that was at one time we didn't have the ability to write directly to each pixel very easily, And so we would send ASCII codes to the screen, and you would use these to draw like borders around things using basically ASCII art. So if you get weird characters like that, it's kind of because you're up here in the upper areas of the ASCII code list, and that's why you get those numbers. Not anything you need to specifically know, but I figure this is a good opportunity to give you an idea of how this stuff is working. And so you can see with no null text, you blast through one variable and then go into the other one. And because there is a null character in that last one, it stops it and it does fine. Same thing with no text. We get a bunch of weird characters, then whoops, no null, and then a bunch of weird characters, and then I love C++ because it just blasts through everything until it gets to \0. You're not going to encounter that often, but it's kind of interesting. And if you see weird characters show up on your screen, you could be thinking, somehow I'm doing something with characters and I'm not putting a null character in it. Does that make sense? Cool. I like this stuff because it's kind of neat. It shows how things work underneath, and it demystifies things maybe a little bit. Everyone else seen screen freezing? Oh, okay. Probably I just wasn't moving my mouse or something. So when we try to write to no, so this just basically explains what happens. If there's no null character, it just keeps going on. And you see these trash characters. They're not really trash characters, as I showed you with the ASCII list. They're specific ASCII codes. It's just that, whatever you have as numbers there is what it gets interpreted as a character. So cin and getLine hold true when reading character array data. So if you do a getLine, you can actually getLine and notice here we say character asterisk text. So what is text? Normally we put a string in there, but now we're using a character array. So what that is basically, so that's basically a character array. Remember, character arrays are pointers. So this is a pointer to char, and a character array is basically going to be pointing to the first. Text would be a pointer pointing to the first character in the character array, and so this is one way of passing in an array. Notice that we use an overload of the getLine function, which allows us to put an integer, which indicates the maximum number of characters we'll read in. So that's an option there too. And so usually you put the size of the array in there. And if you put that number, it'll read until it sees an enter key or until it has read the max number of characters in the array. It's a good idea to put that number there because if you put anything larger, you'll blast through the end of this array and you might obliterate some other data. So let's try this one. Write the code that will input a name into a 75-element character array called student name. So we want to use some way of inputting that. So I'll give a few minutes or give about a minute for people to answer. Okay, so our declaration is going to be the same. If we're going to do a get line, it's going to be something like this. So we would do get line cin, and then let's see. We don't need that. Or we declare the array. So we're going to get line from cin. Actually, let's see. And then 75. I think that's it. Hold on, let me make sure I got that right. Oh, they used to end out get line. Okay. So actually, it'd be that one. So a little different because a lot of times we're doing get line and put cin in here. This time we're putting cin at the front. And then the 75 basically keeps us from overblowing through the number of characters. Does that make sense? So, there's several useful functions for working with character arrays. And some of these are available in character arrays, are not available in strings. So that's sometimes why we kind of go back and forth between them. So some of the functions are string concatenate. You put two character arrays to the string cat function, and it'll concatenate the two character arrays. Of course, with strings, you could just put a plus. But with strings, we have to use a string cat function. And so they give you the prototype here, and then they give you what it looks like when you call that function. There's also string copy, which will copy one character array to another character array. And there's also string compare, where you can compare two strings to see if they're the same. And so, with our current program, that could potentially be part of the solution. You could compare. So you could maybe take the first 15 characters of the string that you read with let's say that we have apple. I'm sorry, we're doing colors. So let's say we had yellow, YELLOW. So that you could take the length of yellow and then take that number of characters from the string, make a character array, and compare it to to the color, and go through to see if where that string might be located. The probably more useful though is this string str function, where you put two character arrays in them, and it tells you where the index is of the first one in the second one. So if you were to use this with your colors and the sentence that you're looking for the colors in, this would tell you where the first one occurs in the second one. If it didn't find it, it would return null. So you could loop through all the colors and see if they show up in the sentence. If they do, then you would do the swap out. And if it's null, then you would go and grab the next one and just do that with basically a for loop. And let's see. Yeah, and so this would be the use. It says character point. You would say character pointer equals this. If it and notice it returns a pointer. So to find the character at that pointer, you would have to put an asterisk in front of it, and then Yeah, so that's what we just looked at. String length returns the length of a character array, and then string copy copies characters from one source to destination. So this could be useful too, because if you needed to just grab a certain number of characters from your array, then you could just say, I want the next 10 characters or whatever. So let's see, it's 12:47. I'm going to get set up for a demo. Let's see what I've got. Actually, I don't think I've got. Do I have a character array demo? Yeah, I don't think I've got a demo for this one. So let me look up. So let's take a 10-minute break, and then let me look up some stuff, see if I can find some things that relate to this program. So we'll reconvene at 1 o'clock.
Okay.
All right, so what I want to do is we need some capabilities in this program that we need to find. And so what I want to do is I'm going to show you kind of what my program life is more often like, which is, believe it or not, I actually don't remember everything about programming at every given time. So I'm constantly looking things up. So in this case, one of the requirements is we need to see if a color is in is in the sentence. So what I might do is I might say, well, I'm looking up C++, and I want to see, is there a way, actually before replacing string, maybe is there a way find string, some kind of find string function. Yes. Google is your friend. In fact, one of the capstone requirements at the end is we ask you to talk about 3 instances where you've looked stuff up in Google and how you used it in code and provide example of that code. So that's actually one of the primary skill sets that we use as programmers. And it doesn't have to be Google. You can use Bing. Anybody use Bing? Okay. Anyway, so Googling. Actually, Bing is probably fine. Yeah, DuckDuckGo could work. And I'm thinking if you're looking for Microsoft topics, I need to compare what a search in Bing does versus a search in Google. But so I'm going to, I'm just going to put, if I'm searching for something, I'm just going to put the name of the programming language, and then kind of just what I want to do. I want to find a string, and then I look at the results, and you start to learn to recognize certain sites and what they're good for. C++.com often I think is a little bit more rigorous site as far as how they talk about how their documentation is put together. So I would categorize this as a documentation site. Geeks for Geeks and Stack Overflow, those are more discussion sites. All of these can be worked together, and then of course you could also put down site : Microsoft.com, and this site keyword, if you spell it correctly, will just filter out all the this will make sure that this would mean that you'd just be looking for Microsoft documentation. So when you're searching for things, you can try the search just widely throughout the web, or you can say site : and then Microsoft.com and just search for, documentation. And between, you really kind of have to use, it's useful to use all of these. I'm going to look at the C++ site, and then I might go look at what I got from Microsoft, basic string class, and then see what these are there. And then if I go back, maybe I'll look at what Stack Overflow. And I might start off with looking, at Stack Overflow. Is there a function that returns true if the string is found or false if it isn't? And then they have this big long discussion. And then they have a little code. If s1.find s2, hey, that looks interesting. So a lot of times when I'm reading Stack Overflow, I might not, their answer may not be related to what I want to do, but I might see, hey, there's this string find function. And, one of my links had string find. And we can see that C++ is much more in a documentation format. So a lot of times I use Stack Overflow to just kind of give me a hint for keywords I want to look for, I might look for later. And in this case, I got lucky because it already pointed to that. And then I see this one searches the string for the first occurrence of the sequence specified by its arguments. When position is specified, the search only includes characters at or after the position. And let's see. And so here's the different overloads. And it has the find function, and there's different overloads, which means that there's different way of calling this. You can pass in a character array, or you can pass in a string. And then you can also set up a position. By the way, when you see this equal sign here, that means it's an optional argument. I think we may have discussed that a little bit. But that means if you don't specify it, it's going to start from 0. If you do specify it, it'll start from 1. And then I go down and I can look at the examples. So we declared 2 strings here. And there are 2 needles in this haystack with needles. Find string needle. If I find the first one, then it says it found it. So maybe what I'll do is I'll just experiment with this. So I will get a program, and I'll just get a start program, and I'm just going to and this will not be the main program I'm working on. I just say, well, let's see. I'll just declare 2 strings equals blah blah test blah blah, and then I'll say string we'll call it str1 or sentence. Maybe they'll do it that way. And then I might say string word is equal to test. And then let me see. I go back to my documentation here, and it says, we know that since we're using namespace standard, we can ignore these standard : makes it easier. It says found equals, and it says size t. What a size t is kind of like an integer, but it's no positive or negative. It's just a positive number. Size equals found is equal. So I'm going to take basically that. I think that's the main part of what we're doing here, and I'm going to do that, and then I'm going to see out found at found. And this is really, in my case, I'm using sentence and word. and then I'm just going to run that and see what I get. Is it still frozen, Sean? Okay, just a momentary glitch.
Hello.
Hello.
Hello, is Tom there, please?
Yes.
Okay.
Hi, this is Diana with CNN Community College, and I called and spoke with my director, and he said you can come by tomorrow to pick up the keyboard. Normally we schedule you a specific time. Is there a time that it works for you?
Anytime.
Like between
Anytime.
10 and 11?
Somebody might want to
please.
mute, please. Go.
10 o'clock?
Oh.
Yes, ma'am.
Okay. I'll put you to arrive about 10 o'clock. I need you to go to main campus on the south side of the SRC building. Are you familiar with that building?
No.
Where the library is?
Let me look up the, and then.
Okay.
Okay.
Can you tell me what building again, please?
We'll pause for a second.
Student Resource Center?
Oh, SRC. Yes, I do.
Okay, so the south side of that building, there is a parking lot. And in that parking lot,
All
there
right,
is
let's
a
see. Do I
roll-up
have a
garage
way
door.
of controlling? Nope. Hey,
Okay.
And so I will assign my director that ticket, and I'll let him know you'll be there at 10
Tran, can you
o'clock
mute?
tomorrow to pick up a keyboard.
All right.
All right.
So when I
Is
get
there anything else I can help you with?
so when
Pardon?
so when I get there, do I need to call somebody? I just wait.
Get out, and there'll be...
okay, I finally figured out how to mute someone else's button. All right, everyone with me? I did not know I had that control. I learned something today. Okay, so back to here. Let's see, do I have time? Okay, so when I ran this, then I can see found at 10. So this can be useful to us, right? If we know so in this case, it'd be color. Like if I was looking for red, and there's red in here, then let's see. I'm going to run this. And you can see, look, if you have the color, then you can find it in the sentence. Does that look like that would be helpful? So this is the documentation link. I'll post that there. Now, the other thing that we might want to know is let's see. How do I replace a string in C++? And again, we see, hey, look, there's C++.com. I'm going to go to that link, and it gives me a some more documentation, and I can, this is not written easy to read, but I think as you're starting, if you may at this stage, it's going to be hard for you to read through this and say, okay, that's a reference to a string, and what does this end up looking like? Often what I recommend is when you're reading these documentations, see if there's examples at the bottom and read through those, then go back through and try to decipher what's going on. What they generally do with the documentation is they give you the parameters for the functions. In this case, we have the string replace function. And because I burned some time here, we might have to go over this a little bit later, but the string.replace is we're going to replace from one position to the next. So we might do something like this. Size T found is there, and then what we might do is say sentence dot replace, and it's kind of cool because you also notice the IntelliSense kind of tells you what's going on a little bit. And we're going to replace, maybe we'll say, let's replace at found, and we're going to replace, since it's 3 characters, 3 words, and then maybe we can put in blue. Let's see if that works. Oh, I needed to also output that. So C out, new sentence. And I need to store this, so I'm going to say string new sentence is equal to that. And I can see now the new sentence, I found the red at 10 and I replaced it with blue. Does that make sense? That kind of gives you so those two, I think those 2 string functions kind of give you what you need for this this program, or at least that one part, that replace part of the program, and that's using those string functions. So I'll post this recording, and then the link to that documentation to help you out, and hopefully that gets you part of the way there. So that's all I've got time for, and I'll see you all next time. Thank you very much.
Thank you.
Yes, I recorded this. Hopefully it'll work.